So let's get started. Let's create a circle. Let's make an orientation ZX. Increase the divisions. Set open arc to get just the outline. And scale it down a little bit. Let's start by creating particles that will spread apart with a small age. Let's create a pop network and create an initial velocity. Let's create a wrangle and write that velocity is equal to position. Let's check it out. Okay, good. Let's add a little random to the velocity. We just need a random on X and Z. Yes, you can see that the particle velocity has become more varied. Now let's reduce the constant birth rate, because we need very few particles now. Let's make the particles emitted for the first 4 frames. Lifespan and variance set to 0.25, and we can also make them fly out a little faster because we need a stronger impulse here. To do this, increase inherent velocity. These particles I will use as source for pyro simulation. Let's create a pyro source and select preset, source smoke. We have density and temperature attributes. Now let's create volume rasterize attributes. Choose density and temperature. I'll make dark background so that it will be better to see. Let's reduce the voxel size. Voxel radius is still quite large, so we have smaller particle separation. To get rid of such square voxels, we should switch on normalize by clamped coverage. This way, the values will be softer. And now let's add velocity blur to get the trail. Let's set the value to, for example, 4. Okay. But now the offset is ahead of the particle itself. So to fix that, we'll set the shutter offset to -1. Okay, great. Let's create a null and rename it. And now let's get to the pyro simulation. Create a DOP network. Connect it to the first input. Here we create pyro solver. Smoke object, and volume source. In volume source, switch input to first context geometry because we will connect source to the first input. Now we need to specify which fields to use. To do this, you can switch to any preset and then select source smoke again. And just get the required fields, density, temperature, and velocity. In the smoke object, reduce the division size because the simulation now looks very low res. Now let's create gas resize dynamic so that the container dynamically changes size. The default settings here are correct, but let's disable clamp to maximum so that we don't limit the boundaries by anything. Okay, everything works correctly. Now let's turn on two-dimensional and set ZX plane. Okay, now let's add some detail. Select Pyro Solver, Shape, Turbulence on. I think we have a pretty big swirl size right now. Let's go to the Turbulence tab and decrease the value of swirl size. Switch on confinement and increase the value. This is a force which amplifies existing vortices with the intent of undoing the diffusion that occurs during the diffusion stages of the fluid solve. In general, you can try to use the values that suit you best. If you increase the swirl size, you will have such big swirls. If you decrease it, you will have such small details. Well, I'll put something in the middle, and I'll add more swirl to get more small details. Okay, great. The simulation is pretty fast now, so we can reduce the time scale. Let's check it out. Yeah, that's better. And we'll also reduce the dissipation so that the density dissipates more slowly. And we can make the simulation a little bit more detailed by setting the division size to 0.01. Okay, looks good. We can add more detail, but we're only going to take away the velocity for particle advection field from here. So we'll move on to the next step. Now when we look in DOPNet, we can't see anything, so we need to import the fields. Let's create a DOP.io. We specify the path to the DOP network and to the DOP node. That is the path to the smoke object. You can select and press CTRL-C and then CTRL-V. Let's see, and we don't see anything because we need to select the fields to be imported. Let's use preset. Let's select smoke. A lot of fields have been created here that we don't need, so let's delete the unnecessary ones. Let's put only density and velocity fields. Let's check. Yes, there is a density and velocity field. Good, let's move on to the next step. Now we're going to do particle advection by pyrovelocity. I'm going to use density as the particle source. Plug it into the first input. And we can see that now particles are created everywhere, not just where density is. This is because POP network uses the velocity field to generate particles as well. To avoid this, let's remove the velocity field. Since there are 3 velocity fields, we put an asterisk here to remove all velocity fields at once. Check, only the density field is left here. Yes, now particles are born only where there is a density field. The next step is to add particle advection. Let's connect the simulation to the second input because here we already need the velocity field. That is, for understanding, let's create null and rename it to density. In the second input, let's rename it to vel. We go into POP network and create POP advect by volumes. And you can connect it to the second or third input. In this case, we will not see much difference. And we specify that velocity is taken from the second context geometry. Yes, everything works. But now the particles are flying around a lot. Let's switch advection type to update velocity. and switch advection method to trace for more correct results. Let's check it out. Okay, good. Let's see if this is consistent with pyro simulation. I think we can do a timescale of 0.5 here as well. Yes, great. Now everything looks correct. The particles stop at some point. That's because the density is dissipating here. Let's switch off dissipation altogether so that the density is retained for as long as possible. Okay, great. So the particles don't stop. Now let's set life expectancy to 2 and variance to 0.5. And increase the number of particles. Now let's color the particles. Create a pop color and enable ramp to use normalized age. You can also color by velocity. Let's copy the pop color and choose preset. Speed. Here the result is a bit different. The higher the velocity, the whiter the color is. But let's keep the first option, color by normalized age. And now let's make a cache of this simulation. Now let's talk a little bit about optimization. Let's see how much this cache takes up on the disk. It's about 14.5 gigabytes, because I've left all the attributes on. Let's create attribute delete. Enable delete non-selected. We'll need the CD and ID. We don't need all the other attributes. Hit save to disk again. Check again. The total size is now 5 gigabytes. This way the viewport will load the files much faster. Okay, now we can move on to the next step. Now let's color these particles. Let's create a node color. Ramp from attribute. And write CD. Let's do different shades of blue. We can do several, so that it all sparkles on the render. Okay, now we can move on to the next step.